Botix Part 3. This is the final leg of this workshop. So in this, we want to look at how the line follower logic works. So we have the sensors built. We built the sensor. We built the drivers for the motor. Now we're going to see how to integrate everything and make a line follower robot with that. So, robot construction overview. So now you might have any of these kits. What matters is that you have a two-wheel drive robot kit. A two-wheel drive robot is nothing but which has two motors driving two separate wheels. One motor for the left wheel and one motor for the right wheel. Most of these robots will have a free rolling front wheel, which is just there for support. So these two wheels drive and this wheel is for support. Okay, so these are also called differential drive differential drive systems, drive robots. The reason being that you can drive them differentially to make them go in any direction you want. So for example, if let's say you drive only this motor, only the left motor, and in this case this is the right, only the right motor and not the left motor, it's going to turn in that specific direction. Okay, let's look at this table here. So if the left motor is driven in the forward direction and the right motor is driven in the forward direction, it will go in the front forward direction. If the left motor is going backward and the right motor is backward, it will go back. If the left is going forward and the right is going backward, then it will make a right turn. If the left is going backward and the right is going forward, it will make a left turn. If the left is stopped and the right is moving forward, it will make a left turn. Similarly, if the left is stopped and right is going backward, it will make a right turn. Left is forward and right is stopped, right turn. Left is backward and right is stopped, left turn. So this is the logic. This is how we will have to control these robots to move around. We'll see how to use sensors to drive this. Now don't panic. This construction for this robot might take probably half an hour depending upon the kit you bought. So in case you have some battery supply on this robot like this, so you can ignore this. You can later on you will figure out how to use it directly. If you have something which can take a 9-volt battery, then it's fine. If not, you can ignore this and go ahead with our what we have prepared so far. Okay, one thing you need to do is you need to identify the polarity of the motors. There'll be two wires coming from the motor like we saw earlier. You need to figure out what wire you need to connect to the positive and what wire you need to connect to the negative in order for the motor to go in the forward direction, and so that we will be able to use those connections. Let's go forward. So this is the IR proximity sensing module. You can see there are different types of sensor modules available, 1, 2, 3, 4. But if you look at it, all of them have 3 pins. So the way these sensors work, most of them, the 3 pins is like one is for supply, which is 5 volt, one is for ground, which is the negative supply, and one will be the output. So this is one of our sensors, one of the sensors which I had designed long time back. So I still use them. I have plenty of them with me, so I use them. So almost all of them are similar to that. So they all have an operational amplifier. They have different types of trim pots. You can see different types of trim pots here. All of them have some kind of a screw mechanism at the top, which you can vary with a mini screwdriver to change the sensitivity. So okay. So now what I would request you to do is to check if your IR sensor is working. So you can give it plus 5 volt supply and ground, and normally there is a onboard LED to indicate if it's sensing something. Right now you can see it's getting power. So if you put your hands in front of it, the onboard LED will go on. So we'll see how that works here. So you can see we've connected this here. So you can see the sensors working. This is the indication LED and the sensor is working. So we'll just take a quick overview of a line follower robot. So a line follower robot is a robot that follows a black line. Normally there is on a white surface or on the ground there is a black tape made with electrical insulation tape. So you can make a line with the electrical insulation tape and the robot will follow that line. When you leave the robot on top of the line, it will follow wherever the line goes. So if you have bends like this in the line, it will follow those bends. So how does it work? So we saw that we built a IR proximity sensor. So IR proximity sensors can detect all colors of obstacles except black. So if we place the sensors facing downwards, okay, the floor, and place the robot on a floor or on some surface, the sensors will detect the surface and it will work. But if there is a black tape on the surface, the sensor will not detect the black tape part. So when the sensor is placed on the white part, it will detect, and when it's placed on the black part, it will not detect it. So there are two states here, floor detected and floor not detected. We can control our motors using these two states and make the robot follow our line. Let's see how to do that. So now you see there are four possibilities here. There is a left sensor and right sensor, left motor and right motor. Both sensors are on the white surface. The robot will move forward. The way we wired this is the left sensor is connected to the left motor. The right sensor is connected to the right motor, meaning which the output from the left sensor will be used to trigger the left motor, and the output from the right sensor will be used to trigger the right motor. So when both are on white, both detect an obstacle and both motors are triggered. So the robot will move forward. Similar to that, when both are on black, normally the end of the line is marked with a tape like this. So when both are on black, the motors will not be triggered and the robot will stop. Now, what will happen? Uh, how does a left turn and a right turn work? Say the robot is going forward and it's going slightly towards the right. So the left sensor will come on top of the black line and the right sensor is still on white. Since the left sensor is on the black line, the left motor will stop working. Only the right motor will work. So this will make a turn like this. So as soon as it starts making a turn, the left sensor will slightly start moving away from the black line and it will be on the white surface again. So the robot will do a course correction and automatically start following the line. Similar to this, when the right sensor comes on top of the line, the right motor will stop working and the left motor will still be running. So the robot will still move forward. As the robot tries to move like this, the right sensor will come away from the black line and again it will start moving in the forward direction. This is how line followers work. Though it's a very basic logic, very interesting one to build. So using the two states, we will control our motors. We will use the output of our left sensor to drive the left motor and the right sensor to drive the right motor. Initially, both sensors will be on the white portion and the robot will move straight. If one of these sensors get on top of the black line, motor on that side will stop turning and turning the robot slightly. The right slight turn will take the sensor back on top of the white surface and the robot would move forward along the line again. So this is the circuit which we are going to build. These are the IR modules, the left module. You can see it's taking 5V supply and ground, and the output of the IR module is going as input to the ULN, and the left pin and the corresponding right pin of the ULN is going to the left motor and the other side is going to the 9V supply. Similar to this is the right sensor. So now what we're going to do is we're going to so one thing is to see how the sensors are placed. The sensors are placed such that they come on either side of the line and the LEDs are pointing downwards. This is how you need to place your sensors. Let's go ahead. So this is the circuit of the simple line follower. Uh,
This is our final circuitry for the simple line follow robot. So we have two sensors here. So let's call this the left sensor and this the right sensor, the left motor and the right motor. What we have here is a 5V regulated power supply with a power indication LED and a ULN 2003. Uh, we have removed all the sensor circuitry which we had earlier, and we are plugging in the sensor module directly. The sensor module, if you look at it, has three wires which is required. Any sensor module, IR proximity module which you take will come out with three outputs. The pin order might be different, but in this module we have like uh, the supply on this side and the supply on this side and the ground on this side and the signal in between. So the supply goes to a 5V here. You can see that both the sensors are plugged in here at the 5V, and the ground goes to the ground here. You can see both the sensors are plugged in here, and the signal wire from the left sensor is going on to the first pin, you can see, of the ULN 2003, and the signal from the right sensor is going on to the second pin. Similar to that, the output from the not the first pin, the 8th pin of ULN is going to the left motor, and from the 9th pin is going to the right motor. That is the other side of the motor is connected to the supply rails here at the top. So this is the final connection. The idea is that when there is a sensor, when the sensor is sensing something, it will give an input to ULN. ULN will then activate the transistor inside it, and then the motor will get activated. The corresponding motor will get activated. That is the logic we have with this circuit. The circuit is pretty easy to build compared to the other circuits which you have been building. So I trust you will be able to build this. Thank you. So guys, we have the ULN 2003. This is input from the left sensor, and this is input from the right sensor. These are the power wires for both the sensors, the supply, and this is the ground for both the sensors. And the output, from the output we can see we have two. This is going to the left motor, and this is going to the right motor. uh, these are one of the leads. For the other lead for the motor is going to the ground rail here, sorry, so to the supply rail here at the top, 9-volt supply. So the motors get an input of 9 volts, and the sensors get an. Hey everyone, this is our first line follower robot which we have built now. uh, So we have the basic circuitry here. You can look at the part. We have placed the sensors here, and we have the line here. This block here at the end, this is going to be the end of the line. This is the line which we want the robot to follow. Now you can see we have placed the sensors here such that if you look at it from here, they're both on each side. One sensor is coming on the other side of the line, and the next sensor is on this side of the line. So how this is going to work is that when one sensor is on top of the line, the sensor is going to get triggered. The sensor is going to be triggered when it's on the white, and the corresponding wheel is going to move forward. So let's assume now this is on the white, and this wheel moves forward. It's going to be on the black, meaning which the other sensor will go on the white, and this wheel will move forward now till it goes to the black. Now the moment this is on the other sensor is on the white, it's going to go. Now this is going to happen so fast that you wouldn't realize that this is happening, and this is how the line follower works. This is how it's going to keep following this line and reach the end of the line. Let's just plug in the power supply and check how this works. Just to show you a demo, you can look at the sensor lights. So as I move, you can see now the sensor on the farther side, this side, has gone off now because it's on top of the black. Now when this sensor goes on top of the black, this is going off. So you can see this is how it's going to go. So I've not connected the motor. I'm going to connect the motor power now. Let's see. You can see that now you can see it's come to a stop because it's at the end of the line. Both the sensors are not detecting anything. Sorry, let me plug this in and we'll take it for another round. Let me remove it. You can see both. So that's a basic line follower. Let's do it once more. Hola, so interesting.
Can we build a line follower with a single sensor? Yes, we can, we have two states, flow detected and flow not detected. So we can add some additional components and build it. Say we use only the left sensor. When the flow is detected, we can trigger the left motor forward and keep the right motor stationary. And when the flow is not detected, we can trigger the right motor forward, keeping the left motor stationary. This will create an oscillating forward motion along the black line. The robot will still be following the black line. And when the black line ends, the robot will make a turn, because when the black line ends, it's going to be on the white surface, meaning which it's going to keep turning, keep turning, keep turning, which is going to be a full about turn. At some point, it'll be back on the line again, and it'll start following the line, black line again. We need an additional component to build this, which is a NOT gate. A NOT gate will invert whatever input it gets and give a output, inverted output. So if a NOT gate gets a 5-volt supply, it will output 0. So I'm sorry, a 5-volt is also called a high, logical high, and a ground is also called a logical low. So when a NOT gate gets an input which is a high, it will output a low. So we're going to use a NOT gate IC, which is 7404, which has 6 NOT gates inside it. So we're going to use only one NOT gate out of it. So we'll use the input 1, output 1 pair, and we need to power the NOT gate with 5 volts. The same logic as what we will be getting from our sensors. Let's see how to do this. So we have the NOT gate here. We've placed the NOT gate. So we are connecting the ground to the NOT gate and then the 5-volt supply to the NOT gate. Now what we're going to do is we're going to remove the second sensor, the right sensor. You can see we have removed the right sensor, and instead of that, from the output of the NOT gate, okay, the second pin of the NOT gate, we are giving an input to the second pin. Now for the input of the NOT gate, we are taking a wire from the first pin of the ULN, which is also the input coming from the left sensor. So we are taking a output, sorry, which it means the output coming from the left sensor. So we are taking a output coming from the left sensor as input to our NOT gate, and the output of the NOT gate is going as input to the second pin of the ULN, driving the right side motor. So this is all the circuit modification we require. Let's see how it works.
So we have the single sensor based line follower here. We have the single sensor based line follower here. We're using a single sensor to do a kind of a oscillating left right motion, and this robot would move. Let me connect the power wire. You can see the way it's moving. Now when it comes to black, it doesn't stop, it keeps rotating, and you can see that it has moved.
That's it, guys. Thank you. Thanks a lot. I hope you enjoyed this workshop. If you have any questions, any feedback, please feel free to write into me. Thank you.